All right. Good afternoon, everybody. Great to be here with you today. We're coming to you from sunny Cleveland, Ohio, at least sunny for right now. But thank you for joining us for the webinar on how chlorine-based disinfectants impact your plumbing systems. My name is Gabe Ellis. I'm the market segment manager for North America Plumbing Materials. So I really work closely with home builders, plumbers, and industry partners to help select and implement high performance plumbing materials that really improve long-term durability and reliability. And I'd like to introduce my colleague and co-presenter, Jonathan Simon. He's the head of sales enablement and analytics. And for over 16 years, Jonathan has been a leader in the residential plumbing industry with a focus on really educating the industry on potential interactions between piping materials and local water chemistry. So just a couple housekeeping items before we jump right into the presentation. Make sure throughout the presentation you use that Q&A button to provide your questions, and then Jonathan and I will look at addressing those, as many as we can, with the time allotted at the end of the presentation. So make sure you submit your questions there. And then we'll make sure to send a recording out to all of you who have attended this live and those who were unable to make it. So we'll go ahead and get things kicked right off here. So really, introduction to water treatment. Water is so important to all of us. With drinking it, going through our homes, powering things. But water in our homes and buildings, it's drawn from lakes, rivers, reservoirs, and underground aquifers. And at its source, water can be a host of, oh man, a variety of different contaminants, ranging from visible solids to these microscopic pathogens that can make us sick. And really that begs the question, how do we make water safe? And this is really important for all of us. Well, this is a diagram showing the methods of water treatment, and you can see all the different stages from pre-treatment to large particle filtration, primary disinfection, fine particle filtration, secondary disinfection, all the way through distribution. But there are three particular disinfectants that are being used. Chlorine. Chlorine, this is free chlorine that's been used. It's an original method of chemical disinfection dating back to the early 20th century. It's fast acting, but it diminishes over time. It can be used in primary and secondary disinfection. It's effective against a variety of different pathogens. But it impacts taste and odor. So it can make your water smell or taste like a swimming pool. But its effectiveness diminishes over time. Chloramine is generated on site by mixing chlorine and then an ammonia mixture, and it came on board in the 2000s. And the EPA really cracked down on this disinfection as a byproduct, leading to a spike in chloramine being used. It's typically used in as a secondary disinfectant. It takes longer to kill pathogens. It has a lower taste and odor impact, but it's highly corrosive with chlorine piping. And Jonathan will talk a little bit about this, but it strips that internal patina away from the inside of the copper piping, creating pinhole leaks. And that really takes us to today, which is chlorine dioxide. It's the newest disinfection technology or disinfectant technology, and it's originally used in the late 2000s or 20th century to address taste and odor concerns, as well as killing certain pathogens that chlorine and chloramine don't kill. And it's the Cadillac of water treatment. It's fast and effective against a broad range of pathogens. There's minimal harmful byproducts, little to no impact on taste and odor. It's actually won awards for the minimal impact on taste and odor, but it's also expensive to implement. And it has a high oxidative reduction potential, which we'll talk about further, that really impacts your plumbing materials and plumbing systems. But at this point, we're going to transition over and kick things over to Jonathan, and he's going to talk through the rise of chlorine dioxide in water treatment and how it's changing.
Excellent. Thank you, Gabe. So like Gabe said, water treatment is changing. It is rapidly evolving. We started off using standard chlorine-based disinfection. That was the go-to for a very long time. Over the last 30 years, there's been a lot more awareness and concern around the disinfection byproducts that chlorine can give off. In fact, in some cases, when chlorine interacts with different types of bacteria, it can create byproducts that are more harmful than the bacteria itself. And that's led the EPA to really take a close look at its regulations. We saw the rise of chloramine in the late 90s and early 2000s, particularly in those areas where disinfection byproducts were a major issue. But we've seen this rise in chlorine dioxide. You can see 15, 16 years ago, chlorine dioxide was very, very limited in its use. But over the last decade plus, we've seen this significant increase. And what's driving that shift in water treatment methods? In 2017, the EPA issued some new regulations identifying Cryptosporidium, Mycobacterium avium, and a variety of other viruses as water contaminants of concern. And what's notable about these particular contaminants is that neither chlorine nor chloramine disinfection is particularly effective at killing these water contaminants. But chlorine dioxide is extremely effective at disinfecting against these elements of concern. Because of that, we have seen this huge spike in chlorine dioxide usage. Since 2020, we've seen it more than double, up 119%. And compared to 2010, it's more than 18 times higher in terms of the usage of chlorine dioxide. And today, we estimate that about 10% of utilities serving a population of 50,000 or more is using chlorine dioxide for either primary or secondary disinfection. And it's spread out pretty well throughout the country. Essentially, any area where the water utility detects any of these contaminants of concern, that's going to be where chlorine dioxide has to be used. So typically what we'll see is a source water location will have a particular contaminant in it, and then any water utility that draws off of that source will eventually need to convert over to chlorine dioxide. We see a lot of heavy pockets of it in areas like Georgia, Alabama, Texas, but we also see a fair amount in the Midwest, in New England, and then even in the western states. In Central Colorado has a lot of chlorine dioxide usage, as does Southern California, the Arizona market, Seattle. Ultimately, as we see the water utilities adapting to these new EPA regulations and identifying what contaminants they have in their systems, we're going to see more and more chlorine dioxide being implemented across this country. And when that change happens, the water utility has no responsibility to notify the home builders, the plumbers, the engineers, or the homeowners. They just make the switch because their responsibility is to keep the water clean and safe to drink. So why is this important for plumbing systems? Well, chlorine, chloramine, and chlorine dioxide all kill pathogens through an oxidation process. Oxidation can also corrode and degrade plumbing systems. And it's a very delicate balance because anything below an oxidative reduction potential of 650 millivolts has very limited disinfection power. So if you're below that 650 level, the water treatment will be largely ineffective at keeping the water safe to drink. But anything over 825 millivolts exceeds the limits of resistance testing for a variety of polymer piping, including PEX and polypropylene. So you have to stay, the water utility has to stay in this very tight sweet spot of 650 to 825 millivolts to have enough disinfecting power to keep the water safe without exceeding the limits of the piping materials in homes and businesses that water utility is servicing. And one of the reasons why this is so difficult is that the oxidative reaction can vary based on a lot of factors. It's not just how much and what type of disinfection the utility puts in, but it can be impacted by pH of the water, with higher pH levels being significantly more aggressive. It can also be influenced by the presence of dissolved metals or oxygen in the water. So even local things within a particular building or a water system, if the building has a copper water main that's coming in that is dissolving copper ions into the water, that can alter the local ORP for that individual building. Even within a building, if there's a metallic component that's experiencing any sort of corrosion, the dissolved metal ions or oxygen that can get into that water can increase the oxidative reduction potential. And then it can also be influenced by the kinetic energy of the molecules. So this doesn't directly impact the ORP, but it does impact the aggressiveness of the chemical reaction. So the kinetic energy comes from higher temperatures, higher velocities, and higher turbulence in the flow. Any of these factors can make the water conditions much more aggressive and more likely to cause corrosion or degradation. In a copper system, excessive oxidation can cause copper corrosion, leading to pipe failures. Now, depending on what type of disinfection you're using, you can see it occur in different ways. Chloramine can be particularly aggressive against copper pipe because it reacts both with the copper itself and the copper oxide patina that can form on the interior of the pipe while it's in service. Chloramine strips that patina, allowing corrosion to persist until the pinhole leaks will eventually develop. Chlorine dioxide reacts in a slightly different way, forming localized cuprite and copper oxide reactions that become very hyperlocalized pinhole leaks. Even standard chlorine can cause copper to experience corrosion, especially when that chlorine exists at high levels. In polymer piping, one of the most common piping systems that you'll encounter, particularly in residential construction, but we're seeing it getting experimented with in commercial construction now, is PEX piping. PEX, or cross-linked polyethylene, is highly susceptible to chlorine-induced oxidative degradation and failure when exposed to hot chlorinated drinking water. You can actually see on the diagram here that green ball represents the chlorine molecule, and whether that's chlorine, chloramine, or chlorine dioxide, it has the ability to reach that interior backbone of the PEX molecule. And when it does that, it actually breaks the backbone, forming microcracks. Those microcracks expand over time, eventually leading to what has been described as mud cracking or multiple pinhole leaks that will develop. And again, because kinetic energy of the water has an influence on this, it happens most frequently on the hot water side and with higher velocity or higher turbulence water. Unfortunately, there have been several significant failures and legal claims that have led the PEX industry to issue specific guidance around chlorine dioxide and chlorine-induced oxidative degradation concerns. The Plastics Pipe Institute, as an example, has issued 2 technical notes on the topic of chlorine resistance and chlorine degradation. The first was Technical Note 53, originally issued in 2017, updated in 2018, and then again in 2025, which defines the limits of the chlorine resistance ratings that are applied to PEX piping. And those limits include any temperatures above 140 degrees Fahrenheit, pressures above 80 psi, or water with an oxidative reduction potential greater than 825 millivolts. Subsequently, in 2023, the Plastics Pipe Institute also issued Technical Note 67, Now, this applies to a wide variety of plastic and metallic piping, but specifically cautions against the use of chlorine dioxide because chlorine dioxide has the unique ability to get above 825 millivolts of ORP at very low levels of disinfection. Subsequent to the issuance of PPI TN67, we've seen several major PEX manufacturers update their manuals to prohibit the use of their pipes or recommend against the use of their pipes in water that's been treated with chlorine dioxide. And each manufacturer can use slightly different language, but we've seen several market leaders saying we do not recommend the use of our pipe or fittings as part of any potable water system where chlorine dioxide is used for disinfection or where chlorine dioxide may be present in the water treatment system. One manufacturer has even gone so far as to directly reference the parameters of PPI TN53, meaning that if you have water temperatures above 140 degrees, water pressure above 80 psi, or an ORP above 825 millivolts, that system will actually be operating outside of the manufacturer's recommendations from their installation manual. So this is a huge issue, hugely impactful to builders, homeowners, plumbers, engineers, because again, you don't know what your water conditions will be over the life of the building. Even if you do a test today, you may not be guaranteed that the water conditions that you find at the moment of specification or installation will be the water conditions present in the building over the course of time. And I'm going to hand it back to Gabe to answer the question that you're probably all wondering about. What about FlowGuard Gold and Corzan CPVC?
Thanks, Jonathan. I appreciate you taking us on a deep dive on water chemistry and its impact on plumbing materials. So what about FlowGuard Gold CPVC? Well, FlowGuard was specifically designed for safe, reliable, hot and cold potable water distribution in North America for residential and commercial buildings. And as you can see, Jonathan touched on, let's go to the next slide here, touched on the molecular makeup of cross-linked polyurethane with PEX. The CPVC is 100% immune to any chlorine-based disinfection in your drinking water. And you can even see in that molecular chain, because we specifically designed CPVC to have chlorine or chlorine in it, those round green molecules representing chlorine bounce right off. It's a part of our molecular chain, and it stands for chlorinated polyvinyl chloride. So as a chlorinated polymer, CPVC is protected against any sort of chlorine attack, chlorine, chloramine, or chlorine dioxide attack. We're 100% immune to any sort of chlorine-based degradation in your drinking water. And since 1959, we've had over 13 billion feet of pipe installed in American homes and businesses. And it's a proven technology against these emerging water treatment methods that are being used today, like chlorine dioxide, which is a big hit with homeowners with reduced odor and taste profiles, and keeping it healthy and our water healthy and safe. Here's a real life case study with chlorine dioxide degradation in Ohio. So the city of Hamilton actually switched to chlorine dioxide for secondary water treatment, and they experienced high rates of failure in their high density polyethylene or HDPE water mains. These failures occurred in cold water HDPE systems. The higher temperatures found in hot water lines can make the degradation even more aggressive in vulnerable polyolefin systems like PEX or PERT or PPR. Actually, the city's executive director of infrastructure said, we've got about 21 miles of HDPE piping in our system now, and it has catastrophically failed almost 60 years ahead of when it should have. So this backs us up about 20 years ago with the future attack on water mains. And unfortunately, the chemicals we use attack the pipes and then cause them to fail. So that's what's happening in cold water systems. Imagine what can happen in hot water lines with additional pressure. So Jonathan even talked through about you can't control when your municipality transitions from chlorine to chlorine dioxide. And that's what brings us to this example. We had a hotel in Hamilton, Ohio experience failures with PEX piping due to the chlorine dioxide generator being installed at the municipal level used to treat drinking water. And they reached out to us because they were having those failures, and they did a complete repipe of their entire hotel in FlowGuard Gold CPVC because they know that our plumbing material has been specifically designed to be 100% immune to any chlorine-based degradation in our drinking water today. So a real success story for us when it comes to the value that FlowGuard Gold brings to home builders, developers, as well as plumbers. But really to recap what we've covered today in our webinar, that chlorine-based disinfectants can significantly reduce the lifespan of some plumbing materials, including copper, like what Jonathan talked about with chloramine, stripping that internal patina away and creating pinhole leaks, PEX and other systems. Chlorine dioxide is certainly, the usage is on the rise rapidly. It's grown 119% in the US since 2020. And utilities continue to adopt it because it kills certain pathogens and bacteria that chlorine and chloramine just can't kill. And it has that reduced taste and odor profile. And FlowGuard Gold is 100% immune to all known chlorine-based disinfections or disinfectants found in drinking water. And it really offers that long-term reliability under these modern practices that are being used. So Jonathan, thanks for taking us on a deep dive on how chlorine-based disinfectants impact your plumbing systems. I think we can just jump right into the Q&A here. We're having a couple technical difficulties, but let me take a look at the Q&A section here. Let's see. Looks like we
have one question.
Yeah, it looks like we have one question here. So one of the questions is, who is responsible for copper or PEX failures? I can take this one while Jonathan's working on getting his sound back. But we actually have an example with a neighborhood in California with copper piping. The municipality switched to chloramines, and homeowners and developers actually sued the water district. And unfortunately, the judge completely threw it out of the court, and it was completely tossed out. And it left the developer and the home builders hung with that sort of responsibility. So unfortunately, you can't determine when your municipality is going to shift from chlorine to chlorine dioxide, and the municipality is responsible directly to the EPA. So their job is to make sure you have clean, safe drinking water, and it's up to the home builder to ensure that the plumbing materials are compatible with the disinfectants that are in your drinking water today.
Sorry about that. I lost control of my cursor for a minute and was unable to unmute myself because technology is always friendly with us. I was not able to hear all of the questions that you were able to get to, Gabe. Were you able to answer the one about 140 degrees?
No, I was able to answer the who is responsible for copper or PEX failures.
Excellent. I see the one here from Ryan asking if at temperatures below 140 degrees, is there any concern with uh, with degradation in PEX tubing? So the short answer is you can have degradation at temperatures below 140 if you have those higher pressures and or those higher ORP values. One thing that you can also find with a lot of these systems is they're loaded up with antioxidants that are designed to protect the pipe for a period of time against this oxidative degradation. But those antioxidants can also be consumed by exposure to things like UV light. So the short answer is it's the combination of temperature, pressure, ORP, and a variety of other exposures that may, over time, weaken or diminish the oxidative resistance of the piping. I have seen, Gabe gave the example in Hamilton, Ohio, a cold water HDPE main that actually failed in relatively fast time frame relative to its expected life. That was cold water, wasn't even operating at extremely high temperatures or high pressures for the system, but because it had chlorine dioxide in it, it was just such a highly aggressive water chemistry that we saw those failures. Um, in fact, when you have that combination of high temperature and high pressure, if you're over 140 and over 80 psi and the ORP is below 825 millivolts, you can still see accelerated degradation. Um, let's see. See another question here from Julie Hagstrom asking if chlorine dioxide affects cast iron waste pipe. I can tell you that we don't have a lot of specific research on that side, but broadly speaking, chlorine dioxide is added to the potable water supply. And when you have potable water going through a drainage system, you're going to have no pressure, and you are going to have a incomplete surface area of that interior of the pipe being covered. So while there's not a lot of research, I can safely say that you're going to have a very different chemical dynamic on the drain waste and vent side, whether it's cast iron or any other sort of material. But there probably does stand to be some research to be done by industry in that area. Overall with the highly oxidative nature of chlorine dioxide.
Looks like we got a question too about the impact of chlorine dioxide on Legionella. I can say chlorine dioxide is highly effective. It's EPA approved for controlling Legionella in water systems, and it is a great disinfectant for Legionella in controlling spread.
We've got a couple more here. So one question is, has the formulation of FlowGuard Gold changed over time where it is now claimed to be immune to chlorine degradation? That's a great question. FlowGuard Gold as a chlorinated polymer has always been 100% immune to the known chlorine-based disinfectants. So we haven't had to update the formula to address this issue. American drinking water has always been chlorinated in some way, shape, or form. So when we designed the molecule, we designed it to be compatible with chlorine-based water. We're talking about it a lot more now because of these dramatic changes in the water treatment system and the fact that there's a number of piping materials out there that don't have this level of chlorine immunity that a CPVC product like FlowGuard Gold or Corzan have. So while it's not a new property for our material, it is something that is newly relevant as water chemistry has gotten more aggressive, and we're starting to see these issues pop up with a variety of other materials.
It looks like we got a question from from Marty, what's the quickest failure on new PEX after installation in a home due to chlorine dioxide? So we have seen with just free chlorine failures in about 7 years. But with chlorine dioxide, we've seen examples of failure in anywhere between 2 and 3 years after installed in a new home.
Excellent. I'm going to run down a couple quick hitters here on the Q&A. Has there been any update on UV protection for CPVC piping outdoors in direct sunlight? So we don't have any updated guidelines on that. What I'll tell you is that with Corzan Schedule 80 CPVC, that is UV stable, so it's readily installed outdoors without the need for additional protection. With FlowGuard Gold, because it's a tan colored pipe, it's a little bit lighter color. It reacts with the UV slightly differently. We do recommend that you avoid installing it in direct sunlight. If you do need to install it in direct sunlight, paint it with a chemically compatible paint. UV will not impact FlowGuard Gold in the same way that it impacts PEX or other antioxidant stabilized polyolefin products, but it will bake the pipe and can lead to some aging. Can this product be used in a plenum space? So yes, both FlowGuard Gold and Corzan are listed and labeled to ASTM E84. We have been used in plenum spaces for decades with no issues. So we are fully listed and acceptable for use in plenums. Let's see, what else do we have?
We probably have time for one more question.
So there's a question here about designing with FlowGuard Gold and the impact that it has on friction loss and head loss. So this is a deep engineering question. So for those of you who aren't professional engineers or get into the weeds on that, I'll give you a really high level answer, and then we can follow up with the engineering audience later with some more details. One of the great things about FlowGuard Gold is because we use socket style fittings as opposed to insert style fittings, we have a significantly lower pressure drop compared to a variety of other materials. So FlowGuard Gold can often be designed along very similar, if not the same parameters as a copper system, because you don't have that extra friction loss caused by the insert fittings. So from a design standpoint, it's actually favorable to go with smaller diameters with FlowGuard Gold, whereas with the PEX system, both because the velocity and the concerns over chlorine degradation and the pressure loss due to the insert fittings, you often need to upsize those PEX systems, which can add cost and increase the wait time for hot water and things like that.
All right. I think that was the last question we're able to get to live here. Thank you, Jonathan. Really appreciate your time with our co-presentation here. I know that there were a variety of different questions that came across in the Q&A. Jonathan and I will take a look at those afterwards and reach out to you directly to answer those questions. We appreciate the participation and you taking the time out of your lunch to come and listen to Jonathan and I talk about chlorine dioxide and chlorine-based disinfectants in your plumbing systems and how they impact it. We'll make sure to send out a copy of the recording, and we hope you have a great rest of your day, and thank you for attending. Thanks again.